So all of you, welcome to this session on oxidation numbers. Fundamentally, what is an oxidation number? It is the apparent charge or real charge carried by an atom or a group of atoms in a given species. So it is mainly meant for conservation of electrons, because one can neither create the electrons nor destroy the electrons during the course of a reaction. A kind of bookkeeping we can call. Now, so the oxidation number is a charge assigned to a particular atom or ion or a molecule in a chemical species. Oxidation number of any neutral atom is taken as 0. And of course, sum of oxidation numbers of all atoms in a neutral molecule is always 0. Now, therefore, if I take, say, sodium atom, its oxidation number is 0. I can take fluorine atom, oxidation number is 0. I can take uranium atom, its oxidation number is 0. So, for any neutral isolated atom, oxidation number is taken 0. It means it has neither taken any electrons extra nor it lost any of its electrons. Now looking at the oxidation number of a fellow can be positive, means it might have lost or apparently lost electrons. It can be negative, it means it might have gained some electrons. Also it can be fractional, interesting, and it can be 0. So now, there are some fellows whose oxidation numbers are universally not changing. For example, in any compound, most electronegative fellow gets electrons, so gets negative oxidation number, and less electronegative fellow in any compound gets positive oxidation number, means it loses electrons. Now let us explore together. Fluorine in any compound, because that is most electronegative element, gets -1 oxidation number. It's always -1. It can never take any other oxidation number. Of course, in free elemental state, fluorine can take 0 oxidation number. But other than this 0 and -1, fluorine never shows any other oxidation state. Similarly, the 1A group metals like lithium, sodium, potassium, rubidium, cesium, francium, in any of their compounds can take +1 oxidation number. Of course, in free elemental state they are also 0, but in any compound they are always +1. Also, second A group metals which are also electropositive, like beryllium, magnesium, calcium, strontium, barium, radium, in all of their compounds take +2 oxidation state. Oxidation number or oxidation state, both are one and the same. Aluminum in all its compounds is plus 3. So these are universally valid observations. For other elements, oxidation states can vary. They may show sometimes positive, sometimes negative, sometimes zero, like that. But usually, in most of the compounds, oxygen is -2. It means oxygen can take 2 electrons if the other fellow has lower electronegativity than oxygen itself. Only one fellow who has more electronegativity than oxygen is fluorine. So whenever oxygen combines with fluorine, its oxidation state cannot be -2. That's why we said usually in most of the compounds, not in all compounds. Secondly, in F2O, because fluorine is more electronegative, oxygen is +2. Thirdly, in some compounds, which we see later on how it can be worked out, in H2O2, oxygen is -1 only, that is in peroxides. Oxygen is -1. There are some compounds called superoxides. For example, it is a superoxide. In a superoxides, oxygen is, this is ordinary oxide, this is peroxide, it is superoxide. In superoxides, oxygen is -1/2. In ordinary oxides, oxygen is -2, in peroxides -1, and in superoxides it is -1/2. So these are the exceptions for behavior of oxygen in several compounds. And now we are looking at the method to find the oxidation number of a given element. Before you do that, here is a general rule, like whenever halogens like chlorine, bromine, iodine are bonded to hydrogen or metals, their oxidation number is -1. But if they are bonded to oxygen or other more electronegative elements, their oxidation number can be positive. So these are the rules of the game. Using these rules, we can find the oxidation number of any damn element. But before that, we see another important thing. For hydrogen, hydrogen in most of the compounds were bonded to more electronegative atoms like fluorine, oxygen, it is +1. When bonded to 1A, 2A metals, hydrogen is -1. They are called in fact hydrides. So these are the general rules. Using these general rules, we can work out the oxidation number of any damn element in any damn compound. For example, we can find what is the oxidation number of carbon in methane. Your rule of the game is whenever hydrogen is bonded to any other element except the 1A, 2A metals, it is +1. You should know that. Sum of the oxidation numbers of carbon and hydrogen put together is always 0 because it is a neutral compound. Therefore, you don't know the oxidation number of carbon. Let us say oxidation number of carbon is X, and there are 4 hydrogens. You know hydrogen is always plus 1. Therefore, 4 times of plus 1 plus X, that is the sum of the oxidation numbers of all compounds is 0. So X plus 4 is equal to 0. It means X is equal to minus 4. In methane, carbon is minus 4. Let's take another example. You want to find what is the oxidation number of nitrogen in ammonia. As usual, nitrogen is not known, X. Plus, there are 3 hydrogens, so 3 times of plus 1 is equal to 0. So X plus 3 is equal to 0. X is equal to minus 3. We can also find the oxidation number of, for example, what is Cl oxidation number in ClO4 minus? It is called perchlorate. Because we don't know the oxidation number of Cl, let us say it is X plus there are 4 oxygens, that is 4 times of minus 2 is equal to sum of all oxidation numbers in a neutral molecule is 0, but because it is a minus ion, it is equal to minus 1. Therefore, X minus 8 is equal to minus 1. X is equal to minus 1 plus 8, that is equal to plus 7. This way you can work out the oxidation number of Cl. Let us take a bit more complicated case. We try to find the oxidation number of for example, oxidation number of let's take K2SO4. You want to find the oxidation number of sulfur. You know the sum of all oxidation numbers is 0. Therefore, we don't know for X, so we say the sulfur oxidation number is X. We work out. There are 2 potassiums. Potassium is always plus 1, so 2 times of plus 1 plus S, I don't know. I say it is X plus 4 oxygens. Oxygen in any case when it is not bonded to fluorine, not in superoxides, in peroxides, it is minus 2. So it is minus 2 is equal to 0. 2 plus X minus 8 is equal to 0. Therefore, X minus 6 is 0. X is equal to plus 6. This way you can find the oxidation number. Now we try to find the oxidation number of underlined species. What is the oxidation number of K manganese in KMnO4? Find the oxidation state of chromium in potassium dichromate. Find the oxidation number of chlorine in perchloric acid. Find the oxidation number of carbon in sodium carbonate. These are all simple cases, but there can be many special cases. How to work out the oxidation numbers in special cases, we see in the next video. Thank you.